Hi guys, so let's solve a LeetCode question today. The question is check if array pairs are divisible by k. Let's first try to understand what the problem statement exactly means. So we are given with an array of integers from elements i1, i2 till in, where the length of the array is n, and we are given with another variable called k. So the ask is to find n by 2 pairs from the array such that for each pair a comma b, sum of both should be divisible by k. That is, the remainder should be 0. So this is the condition, and whenever the condition is satisfied, we have to return true, else return false. So other thing to note here is that in the constraints we are given n as even, so we need not worry about pairing because an array will always have perfectly n by 2 pairs present. And also the integers can be negative as well. So now let's see how we can solve it. Let's see example 1 given in the question, where array is given as 1, 2, 3, 4, 5, 10, 6, 7, 8, and 9. And k is given as 5, where n is equal to 10 because the length is 10, and n by 2 will be equal to 5. So we have to find 5 pairs from this array such that sum of each is divisible by k. Now we start with the brute force approach. So we take the first element, we look for the second number in the remaining array and check if we can get something which gives the sum which is divisible by k. So for 1 we get 9. Now for 2 again we go through the array and we get 8. So for 3, 7, 4, 6, 5, 10. So we successfully get 5 pairs and hence we return true. But as you can see that we are iterating through the array again and again, which will result in time complexity of O of n square. Now let's see if we can optimize it a little and get something more efficient. So whenever you're seeing divisibility in a question, maybe you can think of something in terms of remainders. So what if for each number in the pair, we find remainder of it with k? So for 1, we get 1. For 9, we get 4, 2, 3, 3, 2, 4, 1, 0, 0. Now, if you look at it carefully, you will notice that whenever you sum these remainders, you get it equal to the k, except for the condition whenever you're getting 0 as remainder. So what do we understand by this? Whenever n1 plus n2 is divisible by k, this means that n1 mod k plus n2 mod k will be equal to k. Now, if we simplify it a little, if this is r1, remainder for second number is r2, the sum of both will be equal to k. So if one remainder we have, we can find using k minus r. So this is the main concept we will use to solve this problem. But don't forget that in case of 0 remainders, it will not be equal to 0. I mean, the sum will not be equal to k. So we have to remember this condition is true only when n1 and n2 are not divisible by k. And it's an and. Both should not be divisible by k. So I'll be showing you two approaches to solve this problem. Space and time complexity will be same for both. Only difference will be in the way of solving. But before that, I wanted to mention one more thing, that whenever a number is divided by k, no matter what the number is, whether positive or negative, range will always be from 0 to k minus 1. Now let's see the first approach. But before that, let's also write down the equation that we derived earlier. So this basically means that whenever you have R1 present in array, R2 must be present to form a pair. Note that we don't have to return a list of pairs, instead only a boolean value, so we can create a remainder frequency bucket which will contain count of numbers with the same remainder. Let me show you what I mean. So we create a count array. Let's take the same previous example where k is equal to 5, so the size of the array will be 5 and range will be 0, 1, 2, 3 and 4, like we discussed, 0 to k minus 1. So now the first step will be to find the remainder of each element with k. So for 1, we 1, 2, 3, 4, 0, 0, 1, 2, 3, 4. Now we just count numbers with the same remainder and add it to its respective place. So here this is representing remainder and this is the count. Indexes are remainders and the value is the frequency. So we count the number of numbers with remainder 0, which is 2. For 1 also it's 2, 2, 2, 2. Now, second step is to see the count of remainder pair. Like we check the remainder count of remainder pair, it must be equal to form a pair. So one more thing here is that we will only be checking from 0 to k by 2 times. I mean k by till k by 2. So here k is 5, so it will be 2. So 0 to 2. Why is that? 0 to 2 is still here. Because after this point, we will be just checking the same pair again. So it doesn't make any sense to do that. So that's why to optimize it a little more, we will only be checking till k by 2. Now let's start with I equals to 0. So for I equals to 0, as we know that the numbers with remainder 0 cannot be paired with any other number except for the elements with 0 remainder. And that's why for I0 alone, we will check if the count is even or not. So in our case, the count is 2, so it passes and we go to the next element. So I equals to 1. So now using this equation, R will be equal to 5 minus 1, which is 4. So now our I is 1, R is 4. So basically we check the count for 4 and 1. Is it same? Yes, it's 2 and 2. It's same. So it passes and now we go to the next element, which is 2. So here R will be equal to 5 minus 2, which is 3. Now we check for the next element. So 2 and 3, we see the count, which is 2 and 2. Both are equal. So now a loop ends and we return true. I hope it's clear. So anywhere in between, if we don't get the equal count, we return as false. So now you can see that the iteration through the array had happened only once. So that for the time complexity, it will be equal to O of n plus O of k by 2. which will be equal to O by O of n because k will be a small number. For space complexity, it will be equal to O of k because the max value will be k, like we discussed. The range will be 0 to k minus 1. So for this, we will be using a hash map where keys will represent the remainders and values will have the count. So, but there's a slight more optimization in this approach as we will be storing the remainders based on the requirement. Also, we will be using another variable called pairs in this, which will be initialized to 0. So now let's start the iteration for the above example. I is equal to 0. So R, using this equation, R will be equal to 5 minus 1, which is 4. So initially hash map is empty, so we look for 4. We don't have 4 present in it, so we insert the remainder 1 and we add the value count to 1. Now our I is equal to 1, so R will be equal to 5 minus 2, which is 3. Do we have 3 present in that? No. So we add 2 to it and increase the count by 1. Now I equals to 2. R will be equal to 0 in this case. So in case of zeros, as we know that we only check for the same remainder element. So we don't have zeros present either. We add it to it and increase the count by 1. Now we go to I equals to 3. Again, the value is 0. Now we look for zeros. Do we have any zeros present? Yes. So now we decrease the count by 1 and we increase the pair count by 1. So now hash map will look like 1, 2, 1 and 0, 0. Now we go to I equals to 4. So R will be equal to 5 minus 3, which is 2. Do we have any 2's present? Yes, we do. So we reduce the count by 1 for 2, which is 0, 0, 0, and we increase the pairs count, so it will be 2. Now I equals to 5, so R will be equal to 5 minus 4, which is equal to 1. Do we have any 1 present? Yes, we do. So we decrease the count by 1 and we increase the pairs count by 1. So pairs will be equal to 3. So now we have reached the end of array. So now we check whether the pairs value is equal to n by 2 or not. Our n was 6 and by 2 it will be 3. So yes, a number of pairs are equal to n by 2. So now we return true. Even for this case, the time complexity will be O of n because we are iterating through the array, whereas space complexity will be O of k. Now let's code it up. Now let's start with the first approach. So we start with the first step, which is initialize the count array. So count array will be equal to 0 of k elements because we'll have k remainders. Now step 2 is equal to count the remainders. So for num in array will be rm equals to num mod k. So count array of rem will be incremented by 1. Now we go to the step 3. So step 3 is check pairing conditions. So if count, so we first check for the first element, which is remainder equals to 0. So if count array of 0 mod 2 is not equal to 0, then return false. So this is a special case where rem is equal to 0. Now we check for the remaining element. So for r in range 1 to k by 2. So to include the k by 2th element plus 1. So if count array of r is not equal to count array of k minus r, then we return false. Else we return true. And let's see if all conditions are passing. Let's submit and check. So yeah, it works pretty well. Now let's see the second approach. So step 1 is to declare the count map. So our count map will be equal to dict and pairs will be equal to 0. Now step 2 is to iterate through the array and check for pairs. So for I in array, our remainder will be equal to I mod k, and the complement we will use a variable for getting k minus rem value. So here one more thing to note is that for the conditions where we are getting remainder as 0, to handle that we will just mod it to k. Now we check the condition. So if complement in count map and count map of complement is greater than 0, then count then pairs will be incremented by 1 and count map of complement will be reduced by 1. Else, if remainder is there in count map, you will increase the count of it. Otherwise, we will just add it to the map. Now we return if length of array by 2 is equal to pairs. Let's try to execute and see. Yeah, now let's submit. Okay, it's working. Thank you guys for watching. I hope you got the understanding.